An arithmetic sequence is a sequence of numbers where the increments between the numbers are the same. So you can see that 5 plus 4 gives you 9, and also 9 plus 4 gives you 9 as well. And you get the next number by adding the same number. This same number is called the common difference, and you use D for it. And usually you call the very first number as A1, the next one is A2, A3, A4, A5, although in some cases they name the very first term as A0. Now, one important thing that you have to know is finding the general formula for the given arithmetic sequence. So let's try to figure that out from here. First, A1 is 5, A2 is 9, and A3 is 13. And then to find a pattern, you should think of 9 as 5 plus 4, whereas 13 is 5 plus 4 plus 4, right? Because you started from 5, you added 4 to get 9, and then you added another 4 to get to 13. And this is 5 plus 4 times 2. And then if you do one more, A4 would be like you start from 5, but this time 4 is added 3 times. And so you can write it like 5 plus 4 done 3 times. And at this point you kind of see a pattern here, because this right here, this number is what we call the index. And this is something that's multiplied to common difference 4, and this number here is always 1 less than the index. So you can kind of guess the general pattern here, which is that if you have an, to get an from the very first one, 5 is our a1, right? Then you have to multiply the d by n minus 1. This number has to be 1 less than n. Now often the formulas are written so that d is on the other side, so we can do the same thing. Multiplication is commutative, so you can just write this as this, right? So that's actually the formula for arithmetic sequence in general, which is the important one. And that can actually give us a formula for our arithmetic sequence, because an, the nth term of this arithmetic sequence, is a1, and for us it's 5, and it's n minus 1 times d, and our d is 4. So that's the general formula for an, and you can further simplify this by multiplying by 4, and you get 4n minus 4 plus 5, so you get 4n plus 1 as the formula for our arithmetic sequence. And you can check that this is indeed true just by checking the a5. So what is a5 according to this formula? It's 4 times 5 plus 1, because n is 5, right? So when you set n as 5, this will be 5. 4 times 5 is 20. 20 plus 1 is 21. And indeed, it matches with this one. Now, the way you're going to remember this formula is to think of this entire thing in pictures. So if you have a1, then a2, a3, and then at some point an, how many terms do you have here? There are n terms, and each time you're adding a d, right? So you're adding d until you reach an, and think about how many d's you needed to go from a1 through an. Well, if you have n terms, then how many in-between numbers do you have? You would have n minus 1. This will be like the between spaces, and the spaces between numbers would be 1 less, right? If you have 3 items, you have just 2 spaces. If you have 4 items, you have 3 spaces, and then so on and so on, right? So you can see that in order to go from a1 and to reach an, you have to start from a1 and apply d n minus 1 times. So that's how you can remember this formula from this picture. So make sure that you think of this accompanying picture as you remember this, because this, if you just try to remember this formula, then it's easy to forget. And not only that, there are some cases where people just start with A0, so instead of this being A1 and A2, some people might call this as A0, A1, A2, A3, A4. In this system, what happens is that for this one you have A0, A1, A2, and then all the way up till AN. And because 1 through n is n items, 0 through n would be n plus 1. And therefore, if you think about how many d's you have in between, it's 1 less than the n plus 1, which is n d's. So you'll have n of these. And therefore, when you start from A0, the formula looks a little different. It's AN equals to A0 plus n times d. Again, if you know the picture, then you wouldn't be confused between these two. If you don't know the picture, then it will. I mean, sometimes this is used. Usually, you just have to know this one, but sometimes this is indeed used. So you might as well try to think in pictures, because if you think in pictures, then this also looks natural as well. Yeah, just out of curiosity, if you actually use this one, then for this case, A0 is 5, and then n is n, but then d is 4. So the formula for anth term, an would be 4n plus 5. And this looks different from this formula right here, right? These are different. But this is fine too, because if you look for A4, again, this is 4 times 4, 16 plus 5. It does give you 21, which matches with our naming system, okay? Yeah, but usually we go by this naming system because you can say an is the nth term. So it does make more sense, right? But keep in mind that there are rare instances where they go by this system. All right. You can do the same thing for something called the geometric sequence. Geometric sequence is instead of adding things, you multiply. So here's a sequence where you proceed to the next one by times 2. So 24 times 2 is 48, right? And in that case, the thing that you multiply that's always the same is called a common ratio. So common ratio for this sequence would be 2, and again, our very first term would be 3. And it's the same exact kind of picture. You have A1, A2, and all the way until AN, and you keep multiplying by R, but there will be one less R than the nth term, right? So you end up with AN being A1 times R to the n minus 1. So that's the general formula for it, okay? And also, if you start with A0, it would be slightly different, but I'll leave that to you, okay? All right, so for these arithmetic geometric sequences, what kind of questions can you get? Well, there are many, and you can try some exercises, but I think the following two kind of are probably the most challenging one right after learning the arithmetic sequence and geometric. So let's just do two questions. So here's our first question. You have A2 equals to 6 and A6 equals to 12. Find A11. So how do you get A11? Well, you can just do, like, start from A2, there's some A1, and put 6 here, then A3, A4, A5, and then put A6, and then since this is 12, you can kind of like see how many D's that's needed. So that's like one way to do it, but let's just be more formal so that you don't get confused. So what we're going to do is, because we worked so hard to figure out this formula, an equals to a1 plus n minus 1d, we will just make use of this over and over again, right? And for some reason that you will immediately notice, we want to start from a6. So set n equals to 6, and you get a6 equals to a1 plus 6 minus 1d. And in our case, a6 is 12, and a1 is unknown. That's fine. 6 minus 1 is 5, and d is also unknown. So you have two unknowns, a1 and d, and your goal is really just to come up with an equation for a1 and d. So let's do the same thing for now n equals to 2, and you get a2 equals to a1 plus 2 minus 1d. All I'm doing is I'm taking this and replacing this n by 2. This n and this n by 2. And then just say, since a2 is 6, you have 6 equals to a1 plus 1d. Now the reason I wanted to put the 6 on top and 2 on the bottom is because then I can just subtract the 2, just like that. And 12 minus 6 is 6. a1 minus a1 is 0. See how nice that is? You end up with an equation for just d. So 5d minus d gives you 4d. And therefore d is equal to 6 over 4. And you should probably simplify, because if you don't, then it gets messier. Okay, so they're both even numbers, so you can divide top and bottom by 2. You get 3 over 2. And then, since a11 is being requested, let's think about what a11 is. a11 is a1. Oh, you also need to know a1. So let's go back. So plug 3 over 2 back in there. So 6 equals to a1 plus 3 over 2. Subtract 3 over 2 both sides. 6 is 12 over 2, right? And then 12 minus 3 will be 9 over 2. So a1 is really 9 over 2. Okay, so going back, a11 is a1 plus 11 minus 1 times d, and we already know the values. a1 is 9 over 2, 11 minus 1 is 10, and d is 3 over 2, so that's 9 over 2 plus 30 over 2, because 10 times 3 is 30, and therefore you get 39 over 2 as your answer. Here's a geometric sequence question. This time a3 and a5 is given. Same idea, you start with the formula for an, which is a1, r to the n minus 1, and you start plugging in things. So let's plug in n equals to 5, which gives you a5 equals to a1 times r to the 4 minus 1, and because a5 is 12, you end up with 12 equals to a1 times r cubed. No, this should be 5 minus 1, sorry. Yeah. a1 r to the 4th. Okay, and then if you have n equals to 3, you get a3 equals to a1 r to the 3 minus 1, which gives you 12 equals to a1 r squared. Not 12, sorry. This should be 48. Okay, so now what do we do? Well, we can just divide both sides this time. And the reason that you want to divide is because a1 divided by a1 would cancel. Okay. Well, what's really happening is this. See, think of 12 divided by 48. We know that 12 is same as a1 times r to the 4th. And in mathematics, if two things are equal, we can always replace one by the other. So 12 is now replaced by a1 times r to the 4th. And 48 can also be replaced by a1 times r to the squared. And now you see why we wanted to divide, because then a1 is common top and bottom, which just cancels. And we also know that if you divide and they have the same base, then the exponents subtract, right? And then you can say, well, 12 over 48, well, top and bottom are both divisible by 12. 48 is 12 times 4, so the left side can be written as 1/4, and the right side is r squared. Now here's a very important thing. If you solve this, r is not just square root of 1/4. Well, square root of 1/4 is 1 over square root of 1 over square root of 4. Square root of 1 is 1, square root of 4 is 2, so you have 1/2. But then keep in mind that whenever you take away the square, you could have a plus or a minus. So, this seems like an innocent question, but you actually have to consider these two cases, and depending on what's being asked, sometimes you end up with just a single answer nonetheless, but sometimes you might have two answers, and just writing one of them would not be enough. Okay? Alright, so let's now figure out what A8 is. Oh, but before we do that, I keep forgetting figuring out what A1 is, okay? So whatever that is, since r squared is 1/4 right here, we can say 48 equals to A1 times r squared, but r squared is 1/4. Multiply by 4 both sides, and 4 times 8 is 32, 4 times 4, so I get 192 as A1. Yeah, just do 48 times 4 and you'll quickly see that it's 192. And we get A1 and R, so let's now figure out what A8 is. A8 would be A1 times R to the 8 minus 1, which is A1 is 192 times 1/2 plus or minus 1/2 to the 7th power. And as you can see, that 7th power is an odd power, so you have both possibilities. You can have a plus or minus. So you end up with two possibilities. So when r is 1/2, positive 1/2, what you get is 192 times 1/2 to the 7th power, which is let's see, 192, 2 to the 7th. If you do the calculation, you're going to get 128, but then you have to keep dividing top and bottom. That's hard. Let's see, if you divide top and bottom by 2, it's 96 over 64, but you can divide by 2 again, so that's 48 over 32. Oh, and then you can divide top and bottom by 4, that's 12 over 4 times 8, so 8. And again, you can divide by 4, so it's 3 over 2. So that's what you get. And then when r is equal to negative 1/2, you get a negative because you have 192 times negative 1/2 to the 7th power. So that gives you a negative 3 over 2. So although this looked like a very benign question, there's a potential, there's a trap. If you just write down 3 over 2, that's wrong, okay? So the answer would be either 3 over 2 or negative 3 over 2.